All right, welcome back. We are going to now take our discussions that we did yesterday, measurement of segments, length, and midpoint, that were all done in one dimension, and we're going to move them into two dimensions. So you'll remember that the way we found the distance from A to B, we could either call it the measurement of segment AB, or we could use the shorthand notation of just AB with nothing on top, is we take the numerical value at A and the numerical value at B, and we subtract them. Because we don't know which one is bigger, we put them into an absolute value, and this is called the distance formula. In one dimension, right? It only works if you're going along a number line where you've only got one number to worry about at each point. We also found the midpoint formula, which said that actually, did we talk about the midpoint? I don't think we did. We talked about what a midpoint was, and we talked about the fact that if this is the midpoint, then these two parts are each the same. Did we talk about finding the midpoint? So like if this is the point A and this is the point B, how do I find the value M? I don't think we talked about this. So let's use some numbers. Let's say that this is -2 and this is 12. How do I find out what the midpoint is? Okay, what's the distance between them? A minus B. So I could say that the distance AB is equal to -2 minus 12, absolute value. So that's -14 absolute value. So it's 14 units long. Okay, now what? Divide by 2. So if I take AB over 2, that would be 14 over 2, which is 7. So is 7 the midpoint? How far is 7 from 12? 5. How far is 7 from -2? 9. So is 7 the midpoint? No. So you did 80% of the work right. You recognize that this whole length is 14 units. So we do have to cut it in half and say that we want 7 on each side. But then you have to either add it to the left side, say 7 units from -2. -2 plus 7 is equal to 5. Or you could say I'm going to subtract it from this endpoint. 12 minus 7 is equal to 5. So the midpoint is actually 5. Now, that's a lot of work, isn't it? Turns out that we have another word for midpoint. If you have 2 test scores and you want to find the midpoint between those 2 test scores, what do we call that? The average. And the same works for midpoint. If I want to find the midpoint here, I can just take the 2 values, -2 plus 12, and divide it by 2. That gives me 10 over 2, gives me 5. That'll find the point right in the middle. So our midpoint formula to find a midpoint is equal to A plus B over 2. Okay, I'll have you fill that in just a second on the other sheet. This is all one-dimensional stuff. Today, what we're working towards is two-dimensional stuff. And remember, one dimension means that I can only go left or right, or I can only go up or down. I can't go both directions. If we want to be able to go both left, right, up, and down, we might use a graph like you've used in algebra so much, called a Cartesian coordinate system. And so now what I'm looking for is what if I've got, for example, a point up here that's 5, 4. No, let's go 3, 4. So if this point is 3, 4, and I'm trying to find the length of this segment, how would I do it? Make a triangle, really good. Because if I make this a right triangle, we know that from this point 0, 0, origin, how long is this leg of the triangle? Well, this says that my x value is 3 here. and this was at 0. So I can find this distance using what we did up here, subtracting them. 3 minus 0 is 3. And then when I want to go up this way, I can take the y values, 4 and 0, and subtract them. And so what I'm looking at here is a right triangle where I'm trying to find that hypotenuse. Do you remember anything about doing this? Pythagorean theorem, excellent. A squared plus b squared equals c squared. So I can say that 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. 25 equals x squared. Square root both sides. X equals, when I introduce the square root, I really should do plus or minus. So I'm going to say plus or minus 5. Yeah, it's a distance. So it's got to be the positive one. I'm not going to worry about the negative one. So this length is 5 units long. In other words, the distance here is 5 units. Now, somebody's taken the time to actually put together, what if it's not on the origin here, right? What if I've got a starting point here of x1 comma y1 and an ending point of x2 comma y2? And how could I create a formula for us that lets us find this distance? And the idea is the same. I want to find this leg of the triangle. So that means I subtract the x values. So this length is x2 minus x1. And then I also want to find the length of this side, which will be y2 minus y1. And if I'm looking to find the distance of this segment, the diagonal one, I can do, like you said, the Pythagorean theorem. I can say that this one, x2 minus x1 squared, plus this one, y2 minus y1 squared, equals the hypotenuse, d squared. And I don't want d squared, I want just d. So I'm going to square root both sides. And I get that square root of x2 minus x1 squared plus y2 minus y1 squared equals d. And theoretically, I should do plus or minus. But again, this is a distance measurement, so I only really need the positive one. And I'm going to flip this. I'm going to make it d equals x2 minus x1 squared plus y2 minus y1 squared. And have you seen this before? Yeah, this is called the distance formula. And it really means in 2 dimensions, where you've got an x and a y component. So we're going to use that today, and I'll put that into your notes with you in just a second. So it's already in your notes here. And what we're going to do is use it to find the distance between 2 points. Now, these aren't really great notations, but what does this little 1 here mean? Is that multiplying by 1? This is multiplying by 2. Is it an exponent? What are those? Subscripts. Good. And what they indicate is that they're both x values. This is the x value of the second point. This is the x value of the first point. This is the y value of the second point. This is the y value of the first point. And so they distinguish x's and y's for us. So let's go here and let's say, all right, I'm going to take one of our points, x1 comma y1. What coordinates do we want to use for that? Do we want the top one or the bottom one to be 0.1? The first point. Bottom one? Okay. Here's the origin. When I go left, it's negative, -1, -2. That's my x value, -2. My y value is vertical going down 1, 2, 3, -3. So that's my x1, y1. x2, y2 is this point. So I'll count my x first. 1, 2, 3, 4, 5, -5. And my y is up 3. Having now found my 2 coordinates, I can plug it into the distance formula. And the distance formula starts like this. And I encourage you to write it like that. I think that helps set things up a lot. It would be even more helpful if you told yourself this, like memorize this, because the place that people make mistakes when doing this is they mix this sign up. They put a plus there instead of a minus, or they mix this sign up and put a minus instead of a plus. So I would encourage you to consider memorizing that. Now we're going to put our values in. This is supposed to be x2 minus x1. So -5 minus -2 squared plus 3 minus -3 squared. Pro tip, when we did the distance formula, we had to have it absolute valued, so that when we got -5, it would read as a +5. Why do we not have to do that here? Good, because it's squared. So that does the same thing. -5 as a result inside here gets squared to +25. All right. So -5 plus 2 is -3. I'm going to keep it in parentheses. This is the second place people make a lot of mistakes, is they take away these parentheses and say -3 squared. And if you punch that into a calculator, it'll do the exponent first, and you'll get -9. We don't want that. We want the whole value, which is a negative number, to be squared. And then this one is 3 plus 3, so that's 6 squared. Actually, I'm going to pause for just a second here, and I'm going to ask you guys to get access to a calculator. So I'm asking you guys to use these calculators in class. I like these calculators, not only because they're solar and they won't kill our environment with batteries, but because they show the screen of what you're doing. So for example, if you want to do this problem, you could just do it in sequence. You'll notice here that the x squared button has a little indicator above it that looks like a square root symbol. It's above it because it's got to be the second function used for that button. So if I press the second button and then x squared, it pulls up a square root symbol for me. Now, it automatically inserts a parentheses. It's saying that I'm going to do a parentheses to group all the stuff underneath it. So really, it's adding in a parentheses here. And we're going to want to close one there to say that the whole square root is one chunk. Now we have to open up the parentheses for the -3. So I'm going to press an open parentheses right here. And then I want to say -3. Be careful, this button does not mean -3. This button means subtraction. Instead, I need to come down here to the button next to the decimal point and say -3. Close the parentheses and then square. And then say plus parentheses 6, close parentheses, squared, close the parentheses. Hit enter or equals to finish it. It's down next to the decimal point. Question? Are you using your own personal calculator? Okay, so I won't let you use that calculator on a test. I'm going to make you use these calculators because of exactly what you're looking at. I understand, but what that means for a test is that I would have to go around and ensure that nobody has a calculator doing that for you. That skill of simplifying a radical is a skill I'll be testing. So if your calculator does it for you, it's not a fair assessment. So I'd like you to use this one. I can show you how to fix it so you can do it at home, but practice using these right now because this is what you use on test. So I've just circulated and addressed some mistakes people made when they, for instance, forgot to close this or didn't have a parentheses here, or were using the wrong sign for subtraction versus a negative sign. Once we get this, I want to clarify something. We're supposed to round to the nearest 100th. Let's make sure we know how to round this number. to the nearest 100th. So is this the entire answer?
Yes.
No. In fact, there's more decimals going over here. I can't see it. My calculator only allows for a certain amount of precision. And it's pretty precise. It's providing a lot of detail. I don't need that much detail. I certainly don't want to write it out every time. So I'm going to be telling you in my problems what precision to present your answer to. Eventually, I'm going to ask you to give it simplified radical form, which is precise, the exact number. For now, I'm letting you round it off, but I want you to round to the nearest hundredths. So when we look at a decimal point, for example, these are the ones place, right? Each number in there represents one. These right after the decimal point are the tenths place, which means it's worth 1/10, 1/10. This next one is called the hundredths, which means each number in this second cell from the decimal is worth 1/100. That's what I'm asking you to round to. So in other words, I want you to look at this number and I want you to think about putting a bar after the number 2 digits to the right of the decimal point. But before we do that, we have to decide if the stuff we're throwing away over here is closer to pushing this up to a 1 or whether it's closer to leaving it at a 0. We're going to change this 0 to a 1 or we're going to leave it what it is. In this case, this stuff is greater than 5000000, so it's closer to the top, pushing this up to a 1. So we would put a squiggly equal sign and say 6.71. That's our answer rounded to the nearest 100ths. Questions on that? Okay. Would you guys please now do number 2? Use the distance formula to plug in the values, simplify it, and then use a calculator. If you want to take it one more step here, it'd be great to say like 9 plus 36, square root of 45, and then use the calculator. Okay, so we've just gone over this, checked for understanding. This is our answer. Please make sure you on the recording device know that you did this. I'm going to leave number 3 for you guys to do yourselves. Let's move on to the next point today. Please settle down. Please stop talking. The second thing we're going to do is find the midpoint. And again, we're doing 2-dimensional stuff now. So whereas we had a midpoint formula for 1 dimension, now we got to do it for 2 dimensions. Turns out it's kind of cool. If I'm looking to find the midpoint between these 2 points, and let's say that I'm doing something like 3, 1 here, and this is like 6, no, let's make it 9, 9, 9. Okay. How can I find the midpoint between those? Okay. I like the idea. That's what we did here. The same thing. Somebody said, find the distance, cut it in half. And that gave us the right distance, but then we had to find a way to bring it over to find the actual value. So let me think about this. If I find this distance, I know that this is 6, this is 8. Anyone know what the hypotenuse is for that triangle? Offhand? This is a special one. We'll talk about this later. But 6 squared plus 8 squared equals x squared. 36 plus 64. My pen is dying. 100 equals x squared, so x equals 10. This is called a Pythagorean triple, so it comes out nicely. So if this is 10, that means that each half is how long? 5. But what's the coordinate that would be here? Is it 5 units up, like 8, 6? But how'd you get that from 5? Like, do these distances help us, is what I'm getting at. They really don't, because it's a diagonal distance. And in fact, we're going to get to circles eventually, and we're going to find that there's actually an infinite number of points that are 5 units away from this point. And there's an infinite number of points from this one, and it is the only intersection, but we don't know how to do that yet. So here's the way we do this. It turns out that if I want to find the midpoint between these two, it's right there. Sorry. It's actually the midpoint in terms of the x's, and it's also the midpoint in terms of the y's. Yeah. So if this is x1, y1, and this is x2, y2, first let's find the x value. This is x2, y1. So what's the midpoint of these? Well, the y's are the same. So all we need to do is find the average of the x's. And then what's the midpoint of these two? Well, the x's are the same. So all we need to do is find the midpoint of the y's. So the midpoint is a point, right? It's not a single value. It comes out as a coordinate with two parts. And the x part will be the average of the x values. And the y part will be the average of the y values. So this is our formula. The x of the midpoint, comma, y of the midpoint is the average of the x's, comma, average of the y's. So if I want to find the x midpoint, comma, y midpoint, I'm going to set it up like this. Everyone set this up, please, on your page. Okay. What goes up here? What are these two values? The two x values. So I'm going to take my 7 and my 9. And then what goes over here is -5 and -1. And so 7 plus 9 is 16 over 2, comma, -5 plus -1 is -6 over 2. That's the end of my coordinate, but I can simplify that. What's 16 over 2? And what's -6 over 2? -3. And just gut check. Does 8 fall halfway between 7 and 9? And does -3 fall halfway between -5 and -1? Yeah, so we got our midpoint correct. Please take a moment to find the midpoint for number 5. Go. All right. Please give me a result. 5. I was able to get -20. I feel like I understand this. 3. I didn't get that initially, but I saw what you did. I changed my answer. I feel comfortable now. 1. I got a different answer. I think mine's right. Okay. Okay. The last skill for today is -20 was the correct answer. The last topic for today is finding a missing endpoint. So please read number 6 and talk with your neighbor. What's different about this question? Go. Can I get a volunteer to please explain what makes this problem different? Anyone? Anyone? Bueller? What makes this problem different? Yeah, Marin? So they're giving us one of the parts here. Sorry about the focus here. And they're giving us the midpoint, and they're not telling us what the third point is. So I think there's two ways to do this. The first way is graphically. I'm going to actually do a sketch of this. We know that the midpoint is -1, 2. -1, 2. And the endpoint B is 1, 2, 3. 1, 2, 3, 4, 5. What we're looking for is if this is the midpoint and this is B, should A be up and left or down and right? It's got to be up here, doesn't it? So what we're looking for is where A is, up here. And one way I can see doing this is using our slope triangles. We know that if we were to draw a slope triangle from the midpoint to the bottom point, I could copy this slope triangle, put it up there, and that would tell me what the endpoint is here. So what do I have to do to get from the x value of 3 to the x value of -1? How many am I moving to the left? 4. I move 3 over to the 0, and then 1 more this way. So this would be going 4 negative. And just to check it, if I take 3 and I subtract 4, I end up getting -1. And then what about the y value? I start at -5 and I'm moving up to 2. What do I have to do to -5 to get it up to a 2? Add 7. And just to check, if I put a +7 under here, I get a +2. And that's what I wanted. This is a transformation. In other words, I'm moving this point 4 left and 7 up. If I did it again here, it would take me to my endpoint. You can either do it visually and say, okay, I'm going to go -4 here. I was at -1. If I go -4 more, what's my new x value? -5. I could also then say my y value was 2. I need to go up 7. So what's my new y value? 2 plus 7 is 9. You could do it more graphic or more algebraically, sort of, by saying, here's my midpoint. I've already found my transition from this, my transformation, and I can just put those underneath it. -1 minus 4 is -5. 2 plus 7 is 9. This is one way to do it. It's a graphical way. It may make sense to some of you. I'm going to show you a different way as well. You get to pick which way you want to use. The second way is to recognize we're going to use our formula. Remember that the x of the midpoint, y of the midpoint has this formula, x1 plus x2 over 2, comma, y1 plus y2 over 2, right? This is our midpoint formula. I'm going to suggest that we pull out the parts that are related to x. Aren't those the parts that are related to x? In other words, the x of the midpoint is going to equal x1 plus x2 over 2. And similarly, I could say that the y of the midpoint is going to equal what? y1 plus y2 over 2. So in other words, I've broken our formula into two explicit equations. Having done that, for this problem, do we know the x of the midpoint? -1. We're given x1 of 3, and we don't know x2. So I've got a little algebraic equation. How do I get rid of this dividing by 2 thing? multiply both sides by 2, and I get negative 2 is equal to 3 plus x2. What do I do to get x2 all by itself? Subtract 3, and I get negative 5 is equal to x2. Isn't that what we wanted? No, because it's not square rooted. It's not squared. It's just the subscript of 2. Then we can do the same thing with the y. The y value of the midpoint is 2. The y value given to us is negative 5. We don't know the second y value. So I multiply both sides by 2. And I get 4 is equal to negative 5 plus y2. Add 5, and I get 9 is equal to y2. Therefore, I can say that my coordinate is negative 5, comma 9. Same answer. Just curious, who likes the graphical way? Put your hand up. Hands down. Who likes the algebraic way? Put your hands up. Just about half and half, isn't it? You get to choose whichever way you want to do it. All right, that's what I've got for instruction for today. This packet is your homework. Please finish it up.